Hello my Linyans, this is Teacher Sarah, and today we are going to discuss solving problems involving simple and compound interest. This video tutorial is based from your learning activity sheets in General Mathematics, Quarter 2, Week 2. So bring out your learning activity sheet and turn your learner's module to pages 144 to 167. Our learning targets are compute interest, maturity value, future value, and present value in simple and compound interest environment, and solve problems involving simple and compound interest. Before the lesson, let us have some warm-up questions. I have some questions for you to answer. Question number 1. Blank is an amount of money paid as payment for the use of an amount borrowed or invested. Time starts now. Excellent. The answer is interest. Question number 2. Angel's parents borrow 10,000 pesos for her tuition from a loaning business which credits 3% interest per year. At the end of 3 years, how much Angel's parents pay to the loaning business? Time starts now. Excellent. The correct answer is 10,900 pesos. An investment or a certain amount of money can earn a simple interest or a compound interest. In this lesson, we will investigate, analyze, and solve problems involving simple and compound interest. Let us go back and analyze the given situation in Lesson 1. Suppose you won 10,000 pesos and you plan to invest it for 5 years. A cooperative group offers 2% simple interest rate per year. A bank offers 2% compounded annually. Which will you choose and why? So in the problem, there are two types of offers. For cooperative group, 2% simple interest rate per year, while the bank offers 2% compounded annually. And you will ask to choose which offer are you going to follow. So to think which computation or which type of interest is better, so you may observe the table for investment 1 and 2. So investment 1 is a computation for simple interest. So using the term of 5 years, then the principal is 10,000. The interest rate given is 2%. So the computation for simple interest is the principal times the rate of interest multiplied by the year. So after 1 year, the interest is 200. Then the amount after 1 year, or the maturity value, you added the 200 interest to the principal, so that becomes 10,200. Then in the second year, the interest is computed as 400, then added to the principal 10,000 becomes 10,400. So in the third year, 600 added to 10,000, that becomes 10,600, and so on and so forth. And then for investment number 2, computation of compound interest, same number of years, 5 years, then The amount at the start of the year is 10,000 pesos, same interest rate. The computed compound interest after 1 year, the interest is 200, which is the same as in the computation for simple interest. And then you added this interest to the principal, so that becomes 10,200. But at the end of the second year, so this 10,200 becomes the principal at the start of the second year. So the calculated compound interest is 204, again added to 10,200, that becomes 10,404. So same with other computation up to the end of 5 years. When you compare them at the end of 5 years using the computation for simple interest, the amount after 5 years is 11,000, while the computation for compound interest that offered by the bank, the amount of money becomes 11,040.81. So as a depositor or as the owner of the money, so the question, which offers will you choose? So the compound interest or the offer of the bank is better because your money becomes 11,400.81, which is higher than the computation offers by the cooperative group, which is only 11,000 pesos. So from the table, the simple interest remains constant throughout the investment term, while in compound interest, the interest from the previous years also earn interest. So the interest grows every year in investment 2. So what is simple interest? Using table 1 presented in the previous page, we observe that an annual simple interest rate is based on the 3 factors, namely principal, which is the amount invested or borrowed, simple interest rate, usually expressed in percent, and the time or term of loan in years. Also, simple interest is computed as follows. The annual simple interest I sub s equal to PRT, where I sub s represents simple interest, P the principal or the amount invested or borrowed, R is the simple interest rate, and T is the term or time in years. The maturity value F is computed as F equals P plus I sub S, where F represents the maturity or the future value, P the principal or the amount invested or borrowed, I sub S is the simple interest, since I sub S is equal to the product of P, R, and T. Then F equals P plus PRT, or F equals P multiplied by quantity 1 plus RT. So you factor F equals P plus PRT. Here are some examples that will help you to better understand simple interest. Example 1. A bank offers 0.25% annual simple interest rate for a particular deposit. How much interest will be earned if 1 million pesos is deposited in this savings account for 1 year? So the given are fee equals 1 million pesos. The rate of simple interest is 0.25%. Then first is to convert it to decimal, and that is equal to 0.0025, and the term or the year is 1 year. So you are required to find the simple interest. So solution using the formula as we defined before. I sub S is depend on the three factors, namely P, R, and T, where the P is the principal, R is the simple rate of interest, and T is the term or year. So by substituting all the given values in the formula, so fee 1 million pesos times the rate of interest, which is already converted to decimal point or decimal number, that is equal to 0.0025 multiplied by the given year 1. So the interest for 1 year is 2,500 pesos. So thus the interest earned is 2,500. Example number 2. How much interest is charged when 50,000 is borrowed for 9 months at an annual interest rate of 10%? Given the principal is 50,000 pesos, the rate of interest is 0.10, and T is 3/4 year, or that is 9 months. So you ask to find simple interest. Note that when the term is expressed in month, it should be converted in year. So by T equals number of months divided by 12, since in 1 year there are 12 months. So the computed simple interest, so using the formula I sub S equals PRT, substituting all the given values. So P is 50,000 times 0.10 times 9/12. So I sub S is equal to 3,750 pesos. So thus the simple interest charge is 3,750 pesos. Example number 3. You complete the table below by finding the unknown values. So in the table, there are some missing factors that you are required to find. So for letter A, you ask to find the principal amount. Then letter B, if the principal is 36,000, then that time is 1.5, the interest is 4,860. You ask to find for the value of R, or the rate of interest. Then for the third row, 250,000 pesos is the principal, the rate is 0.5%, and the interest is 2,750. You ask to find for the term or time. Then for the fourth row, principal is 500,000, the rate of interest is 12.5%, the time is 10. You ask to find for the simple interest. Okay, our solution to complete the table to find the unknown principal can be obtained by P equals I sub S over RT. So this formula is being derived from the definition of simple interest, where I sub S is equal to PRT. So P equals I sub S over RT. Then you replace the value of I sub s, which is equal to 1,500 over 0.0025. This is the rate of interest being expressed in decimal, then multiply by the term or time, which is equal to 4. So the principal is 15,000 pesos. And for the unknown rate, can be computed by R equals I sub s over PT. So again, substitute or replace the I sub s, which is equal to 4,860, divided by the principal times the time. So R equals 0.09. Then since the unit for the rate of interest is percent, you may multiply this 0.09 by 100. So that's give you 9%. And for the unknown time, it can be calculated by T equals I sub s over PR. So again, replace I sub s equals 2,750 divided by the principal, which is equal to 250,000 multiplied by 0.005. Then the time is 2.2 years. And for the unknown simple interest, given the formula for I sub s equals PRT, so replace the principal, then the rate, which is expressed in decimal, then the time. So to give you the product, the interest is 625 pesos. Okay, so that's the solution for the unknown factors, no? So to complete the table. Example number 4. This time you find the maturity value if 1 million pesos is deposited in a bank at an annual simple interest rate of 0.25% after 1 year and after 5 years. So the unknown maturity value can be obtained by F equals P multiplied by 1 plus RT. So we derived it already from our previous discussion. So the given are P 1 million pesos, then the rate of interest is 0.25, which is converted to decimal equal to 0.0025, and the term is 1 year. So using this formula, F equals P multiplied by quantity 1 plus RT. So you replace all the given values. So for P 1 million multiplied by quantity 1 plus the product of the rate and the time. So F equals 1,02,500 pesos. This is the future value or the maturity value in 1 year. And then to find the unknown maturity value for 5 years, it can be obtained by the formula F equals P times quantity 1 plus RT. So the given, we have 1 million for the principal, then R is 0.25%, or that is equal to 0.0025, and the term is 5 years. So using the formula to find the future value, so just replace all the given values. So F or the future value is 1,012,500. So thus the future value or the maturity value after 5 years is 1,012,500 pesos. Then for compound interest, many bank savings account pay compound interest. In this case, the interest is added to the account at regular intervals, and the sum becomes the new basis for computing interest. Thus, the interest earned at a certain time interval is automatically reinvested to yield more interest. The following table shows the amount at the end of each year if principal P is invested at an annual interest rate R compounded annually. Computations for the particular example, P equals 100,000 and R equals 5% are also included. Okay, look on the given table. First column is the time or the term, then the second column is the amount at the end of the year, and the third column refers to the amount at the end of the year using the principal as 100,000 pesos and the interest rate is 5% compounded annually. So observe that the amount at the end of each year is just the amount from the previous year multiplied by quantity 1 plus R. In other words, 1 plus R is multiplied each time the year ends. This results in the following formula for the amount of 30 years given an annual interest rate of R. So maturity value and the compound interest formula. For finding the maturity value based in the table presented, so F equals P times quantity 1 plus R raised to T, where P is the principal or present value, F is the maturity or the future value at the end of the term, R the interest rate, T the term or the time in years. And to find the compound interest or I sub C is given by I sub C equals F minus P. Example 1. Find the maturity value and the compound interest if 10,000 pesos is compounded annually at an interest rate of 2% in 5 years. So given P is 10,000 pesos, R is 2% or 0.02, and the term or time is 5 years. So you ask to find A. Maturity value F, B. The compound interest or I sub C. Then to find letter A or the maturity value using the formula F equals P times quantity 1 plus R raised to T, substituting all the given values, F equals P is 10,000 pesos times quantity 1 plus R is 0.02 raised to T, which is equal to 5. Then to compute these values, so F equals 11,040.81 pesos. And to get for the compound interest, after solving for the value of the future value, so by getting or by subtracting the present value from the future value, I sub C is equal to 1,040.81 pesos. So the future value is 11,040.81 and the compound interest is 1,040.81. Example number 2. Suppose your father deposited in your bank account 10,000 pesos at an annual interest rate of 0.5% compounded yearly. When you graduate from kindergarten and did not get the amount until you finish grade 12, how much will you have in your bank account after 12 years? So again, identify all the given values. P is 10,000, R is 0.5% or 0.005, and the time or term is 12 years. So find the future value. So to find the future value, it is calculated by F equals P times quantity 1 plus R raised to T, substituting all the given. We have 10,000 pesos, substituting all the given. We have 10,000 pesos times quantity 1 plus 0.005 raised to 12. Therefore, the future value is 10,616.78. So thus the amount will become 10,616.78 after 12 years. To find the present value fee at compound interest, so the present value or principal of the maturity value F due in T years at any rate R can be obtained from the maturity value formula F equals P multiplied by quantity 1 plus R raised to T. So solving for the present value, so using the formula to find the future value, F equals P times quantity 1 plus R raised to T. So by dividing both sides by 1 plus R raised to T, so phi equals F over quantity 1 plus R raised to T, or P equals F times quantity 1 plus R raised to negative T. So by putting the denominator quantity 1 plus R raised to T in the numerator, so the T or the exponent T becomes negative. So you can use these two formulas in order to find for the present value at compound interest. Example number 3, what is the present value of 50,000 pesos due in 7 years if money is worth 10% compounded annually? So first, identify the given. F is 50,000, R is 10% or 0.1, and T or term is 7 years. So find the present value P. Then, the present value P can be obtained by the formula derived from a formula of future value. So P equals F over quantity 1 plus R raised to T by substituting the values. So F is 50,000 divided by 1 plus 0.1 raised to 7. So the present value is 25,657.91. Or using the alternative formula to get the present value, P equals F times quantity 1 plus R raised to negative T, where P is 50,000 multiplied by 1 plus 0.1 raised to negative 7, P is also equal to 25,657.91. So thus, the present value is 25,657.91. Compounding more than once a year. Sometimes, interest may be compounded more than once a year. Consider the following example. Given a principal of 10,000 pesos, which of the following options will yield greater interest after 5 years? For option A, earn an annual interest rate at 2% at the end of the year. Or option B, earn an annual interest rate of 2% in portion 1% after 6 months and 1% after another 6 months. So for option A, interest is compounded annually. So from the table, so the principal is 10,000 pesos, the annual interest rate is 2% compounded annually. So after 1 year, or at the start of 1 year, the amount at the end of the year is 10,200. At the start of the second year, the amount at the end of the year is 10,404. Then 3 years, 10,612.08. Fourth year, 10,824.32. And in the fifth year, 11,040.81. So for option B, interest is compounded semi-annually or every 6 months. Under this option, the interest rate every 6 months is 1 year. 2% is divided by 2. So here is the table. Observe the table. So every 6 months. So 1/2 year, the amount at the end of the year is 10,100. After 1 year, 10,201. 1.5 year, 10,303.01. And after reaching the end of 5 years, using that interest rate every 6 months is 1%. So the amount at the end of 5 years is 11,046.22. Option B will give the higher interest rate after 5 years. If all else is equal, a more frequent compounding will result in a higher interest, which is why option B gives a higher interest than option A. So the investment scheme in option B introduces new concepts because interest is compounded twice a year. The conversion period is 6 months and the frequency of conversion is 2. As the investment runs for 5 years, the total number of conversion period is 10. The nominal rate is 2% and the rate of interest for its conversion period is 1%. These terms are defined generally below. Frequency of conversion represent a symbol M, refer to number of conversion periods in 1 year. Conversion or interest period, the time between successive conversion of interest. Total number of conversion periods N, where N equals MT, frequency of conversion times time in years. Nominal rate represent I raised to M, refer to annual rate of interest. The rate or J of interest for its conversion period, where J equals I raised to M over M equals I raised to M is the annual rate of interest over M is the frequency of conversion period. Note on rate notation. We have a symbol R, I raised to M, and J. In earlier lessons, R was used to denote the interest rate. Now that an interest rate can refer to two rates, either nominal or rate per conversion period, the symbol I raised to M and J will be used instead. Example of nominal rates and the corresponding frequencies of conversion and interest rate for its period. Okay, look on the given table. For the first column, we have the nominal rate or the annual interest rate. Second column is M, represent the frequency of conversion. J for the third column, interest rate per conversion period. And for the last column, one conversion period. For example, the 2% compounded annually, your I raised to 1 means annual, no? Equals 0.02. Then the frequency of conversion is 1. J, you divide 0.02 by M or the frequency of conversion, and that is equal to 0.02 or equal to 2%, and one conversion period is 1 year. For 2% compounded semi-annually, I raised to 2 equals 0.02, m is 2, that is the frequency of conversion, so that is 0.02 over 2 or 0.01 or 1% per day, and that is 6 months because it is semi-annually. 2% compounded quarterly, I raised to 4 equals 0.02, m or the frequency of conversion is 4, then 0.02 over 4 equals 0.005, 0.5%, or that is 3 months. Then for 2% compounded monthly, I raised to 12, that is 0.02, 12 is the m, and j is 0.0016, and conversion period is 1 month. And 2% compounded daily, I raised to 365 equals 0.02, m or conversion period is 365, and j is 0.02 divided by 365, or the conversion period is 1 day. From the previous discussion, the formula for the maturity value f when principal p is invested at an annual interest rate j compounded annually is f equals p times quantity 1 plus j raised to t. So because the rate for its conversion period is j equals I raised to m over m, then the t years interest is compounded mt times the following formula is obtained. So to find the maturity value, compounding m times a year, f equals p times quantity 1 plus I raised to m over m, where f equals maturity value, p is the principal, I raised to m equals nominal rate of interest, m equals frequency of conversion, and t is the term or time in years. Example, find the maturity value and interest if 10,000 pesos is deposited in a bank at 2% compounded quarterly for 5 years. So the given fee is 10,000, I raised to 4 since it is quarterly, 0.02, and the term or time is 5 years, and the frequency of conversion is 4 years. Then you ask to find A, future value, B, the compound interest. So compute for the interest rate in a conversion period by J equals I raised to m over m equals I raised to 4 since it is quarterly over 4 equals 0.02 divided by 4, J is 0.005. And to compute for the total number of conversion periods given by n equals the product of mt, where m is the number of conversion period, which is equal to 4 times the number of years, 5. So n equals 20 conversion periods. Compute for the maturity value using the formula f equals p times quantity 1 plus j raised to n. Substituting the value, p is 10,000 pesos multiplied by quantity 1 plus 0.005 raised to 20. So f equals 11,048.96. And to find for the compound interest, it is given that I sub c is equal to f minus p. So where f is 11,048.96, you subtract the present value, which is equal to 10,000 pesos. So the compound interest is 1,048.96. So another example, Chris borrows 50,000 pesos and promises to pay the principal and interest at 12% compounded monthly. How much must he repay after 6 years? Again, identify the given. P is 50,000 pesos. I raised to 12 since it is compounded monthly is equal to 0.12. P is 6 years. Then frequency of conversion M equals 12. So find the future value. You may also use the other formula to compute for the maturity value. So F equals P times quantity 1 plus I raised to M over M raised to MT, where MT equals N. So P times quantity 1 plus 0.12 over 12 raised to 12 times 6. So F equals 50,000 pesos multiplied by quantity 1.01 raised to 72. So F is 102,354.97. So thus, Chris must pay 102,354.97 after 6 years. So let us now learn how to find the present value when the interest is compounded more than once a year. Present value P at compound interest is obtained by P equals F over P times 1 plus I raised to M over M raised to MT, where F equals maturity or future value, P is the principal, I raised to M is the nominal rate of interest, M is frequency of conversion, and T is the term or time in years. Another example, find the present value of 50,000 pesos due in 4 years if money is invested at 12% compounded semi-annually. So, identify the given. F is 50,000 pesos, T is 4 years, I raised to 2 since it is compounded semi-annually is equal to 0.12. Then you ask to find P or the present value. So first, compute the interest rate per conversion period given by J equals I raised to 2 over M equals 0.12 divided by 2, J is 0.06. And to find the total number of conversion period, N is equal to MT or 2 times 4, the N is equal to 8. Then, the present value can be computed by substituting these values in the formula from P equals F over quantity 1 plus J raised to N. Thus, P equals 50,000 pesos over quantity 1 plus 0.06 raised to 8. So, P equals 31,370.62 pesos. Okay, now, after we discuss the differences between the computation of simple and compound interest, it is now your turn to do your part. Reminder, do not write anything on this activity sheet. Write your answer on a separate long bond paper. For enrichment activity 1, you choose the letter of the correct or best answer, then write your answer on your answer sheet. It's give you 1 point. Then for activity 2, you find the unknown principal, rate, time, and simple interest by completing the table. Show your solution for your answer. Then write your answer on your answer sheet, and it's give 3 points each. For enrichment activity 3, you find the unknown principal P, maturity value, and compound interest by completing the table. Show again your solution for your answer and write your answer in your answer sheet, another 3 points each. And for enrichment activity 4, you read and analyze the given paragraph below, write your answer also on your answer sheet, then it's give you 5 points. And for the wrap up activity, you supply the necessary information about simple and compound interest by completing the graphic organizers below. Copy the graphic organizer on your answer sheet, then write your answer on it. So it's give you additional point or bonus point that should be added in your score in enrichment activity. I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text or post your questions in your official Facebook group or page. Thank you for watching. Don't forget to like and subscribe. Bye!